Hey, let's continue from where we left yesterday. What we were doing was the topic trigonometry. So I'll be continuing from that. Yesterday we covered the basics. Today we are going to take a step forward. Let's see what does that mean. Now I'm going to explain what are the various angles by which we can denote positive x-axis. What I'm trying to say is that if I have the positive x-axis, then how many angles correspond to this line? Let's start with the basic thing. If this is my point and I have to start measuring the angle, then there are two basic conventions or observations that we must remember. The first one is that angle is always measured from positive x-axis. And the second point that we must remember is that anti-clockwise direction, ACW means anti-clockwise direction, is considered as positive. What does this imply? That clockwise direction will be considered negative. If I am measuring an angle in anti-clockwise direction from positive x-axis, then the angle is positive, and if I am measuring the angle from positive x-axis in clockwise direction, then it's going to be negative. So let's observe what is the angle of positive x-axis. Since I'm not measuring in any direction, it's going to be 0. You can call it degrees or radians because 0 is equal in both the unit systems. Now let's observe. If I move 360 degrees from positive x-axis in anti-clockwise direction, then if I'm moving from positive x-axis in anti-clockwise direction, then the angle is going to be 2 pi radians. So I'm going to call it 2 pi radians. What else do we observe? If instead of stopping over here, I move another circle around the origin. Now what is happening? First circle gives me 2 pi radians. The second circle gives me another 2 pi radians. So it's going to be 4 pi radians. Now let's observe another observation, that is, if I don't stop over here and I make another round, what is it going to be? 2 pi plus 2 pi plus 2 pi, that is 6 pi radians. So I'm going to call it 6 pi radians. So now as we observe, different angles correspond to the same straight line, that is positive x-axis. So we come to the conclusion that various angles can refer to the same line. And what happens if instead of, just a second, what happens if instead of moving in anti-clockwise direction from positive x-axis, I decide to move in the opposite, that is clockwise direction. This is my positive x-axis and I am going to move in the clockwise direction. If I move like this, what is the angle measure going to be? The angle is 2 pi, but because I moved in clockwise direction, so I'm going to call it minus 2 pi radians. So I'm going to write over here minus 2 pi radians. Now the second observation, if instead of stopping over here, I make another round. Now what is the angle going to be? The angle is 2 pi plus 2 pi, that will be 4 pi. But because it was in clockwise direction, so I'm going to call it minus of 4 pi radians. Now just bear with me for one more time. If I make another round, what is the angle measure going to be? 6 pi. But because it was in the clockwise direction, we are going to call it negative and it becomes minus 6 pi radians. Is there any observation that you can make in all these numbers? There are 7 numbers, but as we know, they will continue similarly and they will continue similarly. Now the word I used was similarly. How do we understand what is the similarity between all those numbers? Please put your answers in the comments. Let's see. What is happening over here is that since this number is increasing by 2 pi, then again this number is increasing by 2 pi, then again it is increasing by 2 pi. On the other side, it is decreasing by 2 pi and again decreasing by 2 pi. So we can say that all the coefficients of pi, 2, 4 or 6, minus 2, minus 4 or minus 6 or even 0, all these numbers are even numbers. So we can put a generalized formula which says theta is equal to 2n pi, where n belongs to integers. If I put n equals to 0, theta is equal to 0. If I put n equals to 1, then theta becomes equal to 2 pi. If I put n equals to 2, then theta becomes 4 pi. If I put n equals to 3, then theta becomes 6 pi. If I put n equals to 4, it becomes 8 pi and so on. If I put n equals to minus 1, because negative natural numbers are part of integers. Natural numbers 0 and natural numbers with a negative sign, they all constitute integers. So if I put n equals to minus 1, this becomes minus 2 pi. If I put n equals to minus 2, then this becomes minus 4 pi. If I put n equals to minus 3, this becomes minus 6 pi. So we have come to the observation that if someone asks me what are the angles corresponding to positive x-axis, then all those angles can be written as 2n pi, where n belongs to integers. And obviously this term 2n, it will always refer to an even number. So we can say even multiples of pi correspond to positive x-axis. It will be beneficial if you write down this line, that even multiples of pi, that is even 2n pi, correspond to positive x-axis. Now let's move forward to our next observation. Okay, this is my coordinate plane, and now we are going to discuss the angles referring to negative x-axis. If I start measuring from positive x-axis, as the convention says, which we recently discussed, then this angle is going to be plus pi radians. Because I'm measuring from positive x-axis, this is just half of a circle. The entire circle is 2 pi radians. So half of a circle is going to be pi radians. Because the direction was anti-clockwise, it is moving opposite to the direction of clock. So it's going to be plus sign, and the plus will say it is plus pi radians. If I do not stop over here and I make another round, what happens? Pi radians was something that I already had. Now I moved 2 pi further than that previous position, so it will become 3 pi radians. So my new angle will be written as 3 pi radians. Now if instead of stopping over here, I make another round in clockwise direction, what will happen? Excuse me. The previous angle was 3 pi radians. Now I added 2 pi to it. So finally it will become 5 pi radians. So if someone asks me what are the angles corresponding to negative x-axis, then I am going to write down pi radians, 3 pi radians, or 5 pi radians, and so on. The point which we just discussed was more than one angles can correspond to the same straight line. As we saw in the positive x-axis case, various angles are corresponding to this line. Similarly, we can say that various angles are going to correspond to negative x-axis. Now let's observe, if instead of moving in anti-clockwise direction, I had moved in clockwise direction. Just a minute, I'll erase this and draw the new figure. Okay, now if instead of moving in anti-clockwise direction, I decide to move in clockwise direction. But as the convention says, the angle is always measured from positive x-axis. So if I measure from positive x-axis, this is half of a circle, so the angle measure will be pi radians. But since it is being measured in clockwise direction, look, this is the direction in which the clock moves. So it's going to come with a negative sign. The angle is going to become minus pi radians. So I'm going to jot down that value. It can be minus pi radians as well. And instead of stopping over here, I make another clockwise round. So it's going to be minus pi minus 2 pi radians. So finally it will become minus 3 pi radians. So I'm going to write down that value over here. It's minus 3 pi radians. Now let's observe what's happening. If I don't stop over here and I make another round about the origin, what happens? I had a previous angle which was minus 3 pi. Now I moved in clockwise direction by 2 pi. So it's going to be minus 2 pi. So finally it becomes minus 3 pi minus 2 pi, that is going to be minus 5 pi radians. And similarly, this is going to continue over here. What is the observation that you see over here? Please comment. Okay, no issue. Let's see. The value is 1 pi, then 3 pi, then 5 pi, or minus 1, or minus 3, or minus 5. So as we observe, these are odd numbers. And how can I write an odd number? I'll try to explain it with the help of an example. Let's say I'm writing the natural numbers over here. What can we observe? 2 is an even number, 3 is an odd number. So I can say 2 plus 1 gives me 3. 4 is an even number, 5 is an odd number. 4 plus 1 gives me 5. 6 is an even number, 7 is an odd number. 6 plus 1 gives me 7. So I can say that the way to write an odd number is to write even number plus 1. If I add 1 to an even number, I'll get an odd number, because even number are followed by an odd number. So I can say odd number is even number plus 1. And as we just saw in the previous case, we can write an even number by writing 2n. So odd number becomes 2n plus 1. So if I have to write the odd number, that is the odd multiple of pi, as we just saw in this case. So the angles corresponding to negative x-axis are going to be odd multiples of pi. So I'm going to write over here 2n plus 1 pi radians, where n belongs to the set of integers. If n belongs to the set of integers, then 2n plus 1 will represent all the odd numbers. If I put n equals to 0, I'll get pi radians. If I put n equals to 1, I'll get 2 plus 1, 3 pi radians. If I put n equals to 2, I'm going to get 2 to the 4 plus 1, 5 pi radians, and so on. Now, there is another observation. Look, 2 is an even number. If I subtract 1, I'll get 1. 4 is an even number. If I subtract 1, I'll get an odd number. 6 is an even number. If I subtract 1, I'll get an odd number. So another way of writing odd number is to say that even number minus 1. And as we saw in the previous case, even number can be written as 2n. So this will become 2n minus 1. So another way of writing odd number is to write 2n minus 1. So apart from this, I can also say 2n minus 1 pi radians where n belongs to integers. You can use either one depending upon the question. If the question requires you to use 2n plus 1, you can use the first formula, or you can use the latter one depending upon the context. They both are correct. So either you can say 2n plus 1 pi radians, or you can say 2n minus 1 pi radians. I hope this is clear. Let's quickly practice a few questions based on this concept, then I'll move further. If I say this is the coordinate plane, this axis I'm going to name it alpha, I'm going to name this axis as beta, this as gamma, and this as delta. Now I'm going to ask you a few questions. Let's say first one you have to find 30 pi, second one you have to find 45 pi. Please try to solve them in your notebook while I jot down the questions. Then I'm going to provide the solution to each one. Third, it's going to be 90 pi upon 2. Then let's take 47 pi with a negative sign. Okay, I hope you have tried the questions. Let's move further. 30 pi. As we can observe that 30 pi is an even multiple along with pi. And what did we discuss? This alpha, that is the positive x-axis, represents 2n pi radians. And this gamma, that is the axis opposite to positive x-axis, which is known as negative x-axis. This is either 2n plus 1 pi radians or 2n minus 1 pi radians. That is odd multiple of pi. So 30 into pi is an even multiple of pi. So I'm going to name this axis alpha over here. If I have to solve for the second one, which says on which axis will 45 pi lie. 45 is an odd number because it is 46 minus 1 or 44 plus 1. So since this is odd multiple of pi, this is an odd multiple of pi, by definition we can see that such a angle is going to lie on the gamma axis. So I'm going to put gamma over here. Now let's observe the third one. Now this can be simplified and I can call it again 45 pi. So it is same as the second one. So I'm going to say the answer is again going to be gamma, since they both are 45 pi. Now let's observe the fourth one. It says negative 47 pi. Since this is an odd number multiplied with pi, I can write it as odd number multiplied with pi. And what did we discuss in the previous topic? Odd number multiplied with pi brings us to gamma. So I'm going to say the answer is again gamma. I hope this was clear. Now let's move further. Right now we discussed the horizontal axis. And what did we observe? That on the horizontal axis, the angle is either going to be 2n pi, where n belongs to integers, or the angle is going to be 2n plus 1 pi radians, which can also be written as 2n minus 1 pi radians. So the thing which we must remember is that if the angle is a multiple of pi, either even or odd, if it is a multiple of pi, it will always lie on the horizontal axis. Now this is clear. Let's move forward to the vertical axis or the y-axis. If I'm talking about the vertical axis, let's observe what's happening. If I ask you what is the angle made by the positive y-axis, there were two observations that we remembered. First one, that the angle is always measured from positive x-axis and the anti-clockwise direction is considered positive. If the angle is always measured from positive x-axis and the direction is considered sign is considered positive for anti-clockwise direction, then this angle is going to be pi by 2 radians. I'm going to write down pi by 2 radians. And according to what we discussed yesterday, pi by 2 means 90 degrees. And as you can see, this is a 90-degree angle. So I'm going to say that the value of angle is pi by 2 radians. If instead of stopping over here, I make another round, what just happened? I got pi by 2, then I moved further by 2 pi radians. So I'm going to write pi upon 2 plus 2 pi. So right now I'm writing this, but you have to practice it so that it comes on your tips and you are able to quickly answer these. I'm going to help you with a trick. That trick will be a shorthand formula and that will be covered later, but let's just focus at the concept right now. So this is going to be pi by 2 plus 4 pi upon 2, multiplying the numerator and denominator by 2. Now this is equal to 5 pi upon 2. Since the denominators are same, I can add the numerator, so I get 5 pi upon 2. I can say that this angle 5 pi upon 2 radians also refers to the line positive y-axis. Now if instead of stopping over here, I make another round, what happened? I had 5 pi by 2 radians. Now I moved further by 2 pi radians. So I'm going to add 5 pi by 2 radians along with 2 pi radians. What did we just see? 5 pi upon 2 plus 4 pi upon 2 is equal to 9 pi upon 2 radians. Now I can simply write it as 9 pi upon 2 radians. Till now we were moving in anti-clockwise direction. While measuring the angle, I was moving opposite to how a clock works. Now let's observe another case in which I am going to move in a clockwise direction. If this is my coordinate plane, I am measuring the angles corresponding to positive y-axis. If I am measuring the angles corresponding to y-axis, but now I have to move in clockwise direction. And as we remember, angle is always measured from positive x-axis. So this angle measure, the measure of the angle is going to be pi by 2 plus pi by 2 plus pi by 2. So it is going to be pi by 2 added 3 times. So if any number is added 3 times, it is a multiple of 3. So it's going to be 3 pi by 2. So now I can call this angle as 3 pi by 2. But because the direction is negative, so I'm going to say it is minus 3 pi by 2 radians. Now if instead of stopping over here, I make another round, what just happened? I had already covered minus 3 pi by 2 radians. Now I also covered 2 pi radians in clockwise direction. So it's going to be minus 2 pi. And let's just make the denominator common. What do I get? I'll get minus 7 pi by 2 radians. So I'm going to write over here minus 7 pi by 2 radians. Is there any observation that you guys can make on the among the numbers which are written on the board? If you can make an observation, please put a comment. No issue. Let's see. The observation which was quite clear over here is, okay, let's see. 5 can be written as 4 plus 1. 9 can be written as 8 plus 1. 1 can be written as 0 plus 1. So the thing is 0, 4 and 8. There are multiples of 4. So the observation is that a multiple of 4 plus 1 into pi by 2 radians. This is the general term referring to all the angles corresponding to positive y-axis. All the angles corresponding to y-axis can be written like 4n plus 1 multiplied with pi by 2 radians, where n belongs to the set of integers. If n belongs to the set of integers, then 4n plus 1 pi by 2 refers to the positive y-axis. Now let's observe a slightly new concept. I hope some of you might have observed this. For those who did not, let's try to understand what do I mean by that. If I have a multiple of 4, 12 and another multiple of 4, 16, then I can say that 4n plus 1 is equal to 13. 13 is my 4n plus 1. 12 is a multiple of 4. If I add 1 to it, I get to 13. But let's observe from a different perspective. If I'm at 16, 16 minus 1, 15, minus 2, 14, minus 3 is also 13. So if I do a multiple of 4 minus 3, even then I land on the same number. So I can say any number. If I have any number, then this number can either be 4n plus 1 or it can be denoted by 4n minus 3. So 4n plus 1 and 4n minus 3, they refer to the same number. So if I am writing 4n plus 1 pi by 2 radians, n belongs to integers, I can also call it 4n minus 3 pi by 2 radians, where n belongs to the set of integers. As we just saw, multiple of 4 plus 1 and a multiple of 4 minus 3, they both bring me to the same number. So 4n plus 1 pi by 2 radians and 4n minus 3 pi by 2 radians, both will refer to the positive y-axis. So the general angle corresponding to positive y-axis is either going to be 4n plus 1 pi by 2 radians, or it is going to be 4n minus 3 pi by 2 radians. Please note it down, then I'll move forward to negative y-axis. Okay. Okay, now let's discuss the angle measure of negative y-axis. The two observations which we started the lecture today were that the angle is always measured from positive x-axis and anti-clockwise direction is considered positive. So now I am measuring the angle for negative y-axis. If I measure from positive x-axis, then this angle is going to be pi by 2 plus pi by 2 plus pi by 2. So pi by 2 is added 3 times, it becomes 3 pi by 2 radians. So the angle referring to this point is 3 pi upon 2 radians. Now, as you know, I am not going to stop over here, I am going to make another round. So what did I do? 3 pi by 2 plus 2 pi. This can be written as 3 pi by 2 plus 4 pi upon 2. So it becomes what? 7 pi by 2 radians. I am going to write over here 7 pi by 2 radians. If instead of stopping over here, I make another round, what did I do? 7 pi by 2 plus 2 pi radians, that can be written as 4 upon 2, so it becomes 11 pi by 2 radians. So I am going to write over here 11 pi by 2 radians, and so on. And as we know, we are not going to stop over here. Anti-clockwise is followed by clockwise direction. So I am going to say, if instead of moving anti-clockwise, I started moving in clockwise direction. So if I measure the angle in clockwise direction from positive x-axis, then the angle measure for negative y-axis is going to be minus pi by 2 radians. Minus comes from the clockwise direction. So I am going to write over here minus pi by 2 radians. If instead of stopping over here, I make another round, what did I do? I already had minus pi by 2 radians and I moved further by minus 2 pi radians. So it will be minus 5 pi by 2 radians. I am going to write it over here. This is minus 5 pi by 2 radians, and so on in both the directions. What is the observation, if anyone would care to comment? Okay, no, let's see. The observation over here is that this is 0 plus 3. This is 4 plus 3. This is 8 plus 3. 0, 4 and 8. They are multiples of 4. So I can say the general term will be 4n plus 3 into pi by 2 radians. So the general term for angles referring to negative y-axis is going to be 4n plus 3 pi by 2 radians. Now, just a similar concept which we discussed in the previous topic was, if I have a number 12, 13, 14, 15, 16, then if I say 4n plus 3, 12 plus 3 brings me to 15. And I can also say 16 minus 5 is also 16 minus 1 is also 15. So if I do 4n plus 3, I come to 15. If I do 4n minus 1, I again come to 15. So 4n minus 1 and 4n plus 3, multiple of 4 plus 3 and multiple of 4 minus 1, they both refer to the same point. So instead of writing 4n plus 3, I can also write 4n minus 1 pi by 2 radians. So both these angles refer to negative y-axis. I hope this was clear. I'll quickly jot down what we studied today. If this is my coordinate plane, then I'm going to write the angles referring to positive x-axis. The general term is theta equals to 2n pi radians, where n belongs to the set of integers. If n belongs to the set of integers, then even multiples of pi refer to positive x-axis. If I want to find the general term for negative x-axis, then I'm going to say either theta is equal to 2n plus 1 pi radians, where n belongs to integers, that is odd multiple of pi. An odd number can also be written by saying 2n minus 1 pi radians, where n belongs to integers. I hope it's clear that this n and this n, they are different variables. This n belongs to this and this n belongs to this. So I'm going to say either 2n plus 1 pi radians or 2n minus 1 pi radians, plus 1 or minus 1. Now let's talk about the vertical axis. If I want to find the general term for the angles referring to positive y-axis, I'm going to say theta is equal to 4n plus 1 pi by 2 radians, where n belongs to integers, and as we just discussed, this can also be called 4n minus 3 pi by 2 radians, where n belongs to integers. So either 4n plus 1 pi by 2 or 4n minus 3 pi by 2. If I'm talking about negative y-axis, so now I'm going to say theta is equal to 4n plus 3 pi by 2 radians, where n belongs to integers, and as we know, 4n plus 3 and 4n minus 1 refer to the same point. So I can also call it 4n minus 1 pi by 2 radians, where n belongs to the set of integers. The important thing to note over here is that if we are referring to the horizontal axis, then we get multiples of pi. If I am referring to the vertical axis, then what do we get? Multiple of pi by 2. For vertical axis, we have multiples of pi by 2. So if you ever see multiple of pi, then it will lie on the horizontal axis. If you see a multiple of pi by 2, then it will lie on the vertical axis. I hope that was clear. If there are any doubts, feel free to comment. Thank you.